For question number 4, we have the limit as x goes to infinity, and we have an exponential expression. So in this case, we want to log the both sides of that equation because we need to bring down that exponent so it's a multiplier so that we can put it into some ratio form to apply L'Hopital's rule. So here then I get the limit as x goes to infinity of, in this case, bringing down, logging both sides. I'm going to be able to bring down that exponent as 3x, and then I have log of the base, 1 minus 2 over x. So now that I have it in ratio form, what I'm going to do is as a multiplier, I'm going to put it now in a ratio form. So now I have log 1 minus 2 over x over 1 over x, and I'm just going to bring that 3 to the outside here because we don't really need to involve that 3 in the limit. So now when I substitute in, I plug in infinity, I'm going to end up with log 1 on top, which is 0, and then I have 1 divided by infinity, which is 0. Now I have my condition to apply L'Hopital's. So I'm going to apply L'Hopital's here. So in applying L'Hopital's, I end up with log y is equal to 3, and the limit as x goes to infinity, and I end up with 1 over 1 minus 2 over x using the chain rule, so I get times negative 2 over x squared. In the denominator, I end up with negative 1 over x squared. I have some things now canceling out. Those negatives cancel, the x squareds cancel, and so when I simplify this expression, I get 3, and we end up with 2 over 1 minus 2 over x. I can now evaluate this limit. This becomes 3 times, well, the limit as I plug in infinity into this, this becomes 2 over 1 minus 0, or times by 2. Okay, so then, I think I made a mistake here. There was an extra negative here. So it was negative 2 of negative 2, so this is positive, so the negatives do not cancel out here. So I end up with a negative here, this becomes negative 2, so I end up with log y equals negative 6. What I wanted the limit for was for y, so I'm going to solve for y, so y is equal to e to the negative 6.